Power to the truth. This is Margo. This is Monday, November 12th, 2018. I'm going to do a climate update today. I'm not going to be covering sea ice for the North Pole or the South Pole because it just make this update way too long. I'm going to look at the fires in California here from NASA Worldview. We're going to look at climate reanalyzer, we're going to look at some earthquakes, and then we're going to look at data from CAMS with the greenhouse gases, and I've already got all of those pulled up and ready to go. And I know that probably everyone has been following these wildfires out in California. This is from NASA Worldview from today, and the campfire up in Northern California. We can see the smoke here. This is smoke from the fire, and it goes all the way down through the state. And then the other fires are down in the Los Angeles area down here. But so the smoke is kind of spreading out. I'm not sure how much the fire is contained. It was deadly and basically wiped out Paradise, which was a retirement community in Northern California. And this is Chico, that's a small community in Northern California. Yuba City is down here, and the smoke is just intense. And lots of people have died, lots of people are missing. I know that the creatures in the forest were probably, a lot of them probably didn't make it. Pets and livestock and things like that probably didn't make it, you know. So it's just heart-wrenching, and I just feel a profound sadness, not only with this situation, but with the whole world situation. And I've just the last few days, I've been overwhelmed with this profound sadness. And anyway, we have to keep functioning. We have to keep moving forward, no matter how we feel. But this is not too far from the Reno area where I live, and the mountains, the Sierra Nevada mountains, come along here, and then they go over here, and Paradise was actually in the mountains, and Chico's in the mountains. Redding is up here, Sacramento is right down here, and then the San Francisco Bay Area is down here. Now I want to show you the last few days from this smoke. Here it is from the 11th, and here it is from the 10th. This was the day that it was the most intense. Here it is the 9th and the 8th. And here it is from the 7th, which was the day before, where there was nothing. And then the fire started. We can see where it plumed here. And it started on the 8th and grew quickly and just engulfed everything in its path quickly. And people couldn't escape, and they were overtaken by the smoke and the flames, and they just couldn't escape. It was so fast, and the whole town is pretty much gone. So I'm just praying for people's safety and people's well-being. And you know, I do believe we are in the end times, and you need to get right with God and Jesus. You just don't know when your last day is going to be, especially when we have cataclysms and disasters and things like that. things that come up so fast. I mean, if you're caught in the middle of this, and you know, you could go just in a heartbeat, in a second, and you're not going to have time to think about, you know, doing a whole life review and what, you know, which way you're going to go. So now's the time to make your stand and make your choice. Here are the fires down in the Los Angeles area on the 9th. I wanted to show you over here, here it's the Pacific Ocean, and how the smoke spread out and came around. But look at these long lines. It looks like spraying. It looks like long lines of spraying here. So I find that quite interesting in this picture. So that's right over the ocean. And also another thing is, look at the pattern of the clouds. It's like a U shape, and it's almost like something is pushing the clouds away. And the wind was blowing to the west, and we haven't gotten hardly any smoke over here in Reno. And normally when there are wildfires in California, we get the smoke. You know, it just blows over the mountains, and some days it's really bad. But we haven't gotten much because the winds have been blowing to the west. So here it is from the 10th. Look how it just covers up the whole state, and then how it spreads out over the ocean. And here's the 11th, which was yesterday, and so that's where it's dying out somewhat, but it's still going. The smoke is still coming down through the state. And here it is from today. So just praying for everybody's safety and protection during these end times. And this is just an odd looking cloud here. It almost looks like some kind of symbol. It's just doesn't look normal. Look at the angles on that. Almost looks like a 7, and then it's got a tail on the end. It looks like some kind of symbol or character in some kind of foreign language to me. So, you know, I don't know. I have no idea what that is. So we're going to leave NASA Worldview, and I want to show you, I've been saving 2 views from Climate Reanalyzer, trying to on a daily basis. I've been saving the precipitation and clouds view and the snow and sea ice cover view, just for my own, just to look at later and to compare. And here it is from today, and we can see over here off the west coast of the United States, here is this huge area of no clouds, and that's what I was pointing out on NASA Worldview, how it's almost an arc where like the clouds are being pushed away from the state, and then there are no clouds for this whole southwest area. Then they pick up starting in Colorado and New Mexico, and then down into Texas. And I think we had like 1 day of rain in October. And I'm going to go back day by day so that you can see how dry it's been, and how this whole southwest area, we haven't had any rain to speak of. Okay, on Sunday, November the 4th, it was cloud covered. And not much cloud from the day before that. But you can see, like, this whole area is just a lot of blue ocean and not much in the way of clouds or precipitation. The green and the blue. The green is rain and the blue is snow. So you can see, like, no precipitation over here. So the trees are so dry, and all the foliage and the brush, and it's all dead. And so any spark or anything will just set it off and will just blaze. Okay, I'm already back a month back to Friday, October the 12th, and you can see, like, there's been no rain, very little cloud cover. And like I said, we had rain for like one day, the first part of October. Here's the day we had rain, or right around that time. We had a little bit of rain, but all summer long, here's a little bit of rain, but very spotty over California, the northern part in Nevada. But it was spotty Thursday the 4th, Wednesday the 3rd, but then look, before that is like no rain for literally months. We didn't have any rain all summer long. Not a drop. Not a drop. So you want to talk dry. This is dry. This is a dry area. So I'm already back to September the 6th, and this whole area is just like, you know, it's awful. It's almost like something has been pushing the clouds away to keep them from coming over the continent. So look at that. See, it's just a space going out from the coast all the way out, a space of the blue with no clouds, many days. Oh, well, now I'm over. Those are all the pictures that I have. I started doing this on Tuesday, October the 14th. So, and the ice is not coming back well in the Arctic and all that. So I'm going to break out the snow and ice reports and do those separately from my climate updates. So here we are from today on Climate Reanalyzer, and let's look at the 2-meter temperature anomaly map. And here it is from today. We can see it's red up here in Siberia. There's a lot of brown and dark brown up here in the Arctic. We've been having a lot of methane releasing. I'm going to show earthquakes today too. We've been having earthquakes up in the Arctic, and methane right around where the earthquakes are, and thinning in the ozone layer, you know, kind of ozone holes over where the earthquakes are in some of these. And look at Alaska and the Northwest Territories in Canada, they're brown. And then we've got Florida is brown. And then on this view, we can see that Norway and these countries are brown. Novaya Zemlya is all brown. This part of Siberia is brown. A lot of Europe is brown. A lot of Africa is brown. And now Saudi Arabia is all brown. And remember that the Earth is tilting, the north part is tilting away from the sun, and so the southern part of the Earth, the southern hemisphere, is getting more sun now, and so that's going to change where you see some of these temperature anomalies and different things. Look at this, this whole red area with Asia and China, and I don't think, and then up here in Siberia it's brown, and it just like the whole earth is parched, is just parched. Now this is the air temperature. South America, lots of brown. We've got parts in the Antarctic. This western part is all brown, and then the southern part on the Ross Shelf is brown, and then a lot of Australia is brown. And I wanted to show you sea surface temperature anomaly. And this is the temperature of the sea surface, and again what we're looking for is the brown and the reds, and that means they're higher than what they expect them to be from past readings. When we look at the Gulf of Mexico is all brown. We can see off the east coast of United States is all red over here, and then brown, and then it's brown around Greenland, and then up here is where the sea ice has come back somewhat, but wherever the water is coming up and touching the sea ice, it's brown, and then it's brown over here, and then red off the coast of Siberia. When we get to chems, you're going to see very high methane levels being released, and they're also coming out of the Arctic, even through the frozen ice. And this is mushy ice. This is not good solid ice. It's mushy. And we can see brown in the Pacific Ocean and in this Bering Strait, lots of brown there. So all the waters are not looking good. And here to the west of India, that's all brown. And then look at over here to the east of Russia here, that's all brown, and then red over here. Now remember that over here is Japan, and Fukushima is still releasing lots of radioactive water, thousands and thousands of gallons into the Pacific every single day, and that's hot, and so that's heating up the ocean as well. And see, that's all red right around there and coming out from there. And here's the Pacific Ocean. It is primarily brown. And then off the eastern part of South America is red and brown, and then here's a brown spot over to the west, and here it's brown around where the ice is melting from the Antarctic and then around Australia. There's a big brown spot over here to the west as well. So that's kind of all I wanted to cover on Climate Reanalyzer. Now let's look at earthquakes. The first I have the latest earthquakes all around the world for the last 24 hours. This is for all magnitudes, and the red lines are where the tectonic plates are. And I like this view to start with because we can see where all the edges are, and most of the earthquakes are going to happen on the red lines or very near them as you get movement. And the red dots are the most recent earthquakes. So these just happened. There was one down here. When I click on that, it shows up over here. We just had a 4.3 101 kilometers northeast of San Pedro de Atacama in Chile. That's on a red line. Here's another fairly large one. Here was a 5.6 in the Pacific Ocean, the Central East Pacific Rise. This was 10 kilometers deep. A lot of these are kind of shallow. This is for Hawaii. This one 22 kilometers northwest of Pahala, Hawaii. That was 8.6 kilometers deep. Now, what I'm particularly interested in is these earthquakes up here that are happening up in the Arctic Circle off the coast of Greenland. I reported on the 6.8 that happened on Thursday night and Friday morning UTC time, but Thursday night my time. It was right in this same area where this earthquake happened. And so we had a second one happen right in the same area. It was a 4.4 magnitude earthquake, 51 kilometers northwest of Jan Mayen. And remember, I showed you in the I did 2 videos on that, pointing out high methane levels over Jan Mayen and then the ozone hole that developed over that area at the time of the earthquake. So it's in the same place and it's 10 kilometers deep. And then here is this one that happened today. This was a 4.6. It happened 256 kilometers northwest of Andenes, Norway, and that one was 10 kilometers deep. And then we've got a swarm of earthquakes over here in Alaska. This is also in the Arctic Circle, and these are small, but they add up, and so there's a lot of activity going on there. And then we have a lot of earthquakes coming down this red line down along the west coast of North America. And if I click on my plus button, we can zoom in, and we can, because right now they just look like they're on top of each other, but when you start zooming in, you can see that they're pretty much on this red line, the San Andreas Fault here. And this is in California and Nevada, and then up here in Oregon and Washington, and then over here in near Yellowstone. And I believe this one is Oklahoma. This one is Tennessee. The smaller dots are the smaller sized earthquakes. So it is active, things are happening. And I also noticed these are not always from earthquakes. Sometimes I'll see something that says an explosion. And like here's one. Okay, it showed up right here, this red dot. Let me zoom in. This is a 1.2 magnitude explosion, 23 kilometers. Oh, it's up here, this blue dot. 23 kilometers southeast of Sweet Home, Oregon. And it was half a kilometer deep. So I don't know what that's from exactly. You know, we'd have to do some research and see what's up there and see if this was maybe from a rock quarry explosion. Those sometimes register. Sometimes it's an old lava field and there's magma coming up through some of the old volcanoes and it's explosions underneath. Or it could be methane exploding. It could be a lot of stuff. But when you click on it, here's the map and here's where it was, northeast of Eugene, Oregon. So I've seen quite a few of those that just register like an explosion. Sometimes they'll say, here's one, quarry blast. Down here, here's the blue dot down here. So you would think with all the fires and all the stuff going on, they wouldn't be doing this, but this is, you know, they're doing big business. 1.5 magnitude from a quarry blast 4 kilometers southeast of Home Gardens, California, and it was 1.3 kilometers deep. And that was today at 12:35 p.m. my time, or -8 UTC time. So it's right down here. So it's in the Los Angeles area, between Los Angeles and San Diego, right down here. So, you know, they're making stuff happen. And I wanted to show you, I also like to look at this, and this one that I kind of have pulled up all day long is one day of magnitude 2.5 and higher. So there are 22 earthquakes on this map that are 2.5 and higher in the last 24 hours. And then, okay, and on the other one, there were 184 earthquakes in the last 24 hours. But it was so active a few days ago, there were like almost 400 earthquakes in the world in the 24-hour period. Now, this map is 30 days of magnitude 4.5 and higher around the world. And what I want to show you is, now, again, we have the red lines for the tectonic plates. Now, look up here. Here's that 6.8 that happened near Jan Mayen, the 6.8 that happened on November the 9th. And then here's the one that happened in Norway. And then this one happened in Iceland. This was a 4.5 northwest of Iceland on October 23rd, and that was 8.6 kilometers deep. Here's another one that happened off the coast of Norway. This was a 4.6, and then we had a couple of earthquakes happen on the Reykjanes Ridge, and then this down here, this one happened yesterday. This was a 6.2. They called it in the North Atlantic Ocean, but it was actually northeast of Venezuela. It's north of South America, and it was 10 kilometers deep, so it was quite shallow. But all of these are on this same red line, so those were quite large, and you know, 6.8, 6.2, just within a day or two of each other. And then over here in the Pacific, all around the Ring of Fire, we can see it's all been active in Fiji and over into Indonesia and down through New Zealand. And then these southern ridges we've had, it's just been active all the way around. So things are ramping up, and anytime you have earthquake activity, you have sulfur dioxide being released, you have methane being released, you have water vapor being released, you have ozone being released, and it's just a lot of stuff. And a lot of the greenhouse or the gases, the volcanic gases that are released, actually destroy the ozone layer, and we're going to be looking at that now too. So now we're going to look at CAMs. I'm going to start with methane, and I need to pause for just a second. I'll be right back. Okay, I'm back, and I have pulled up here the Copernicus Atmosphere Monitoring Service. They're out of the EU. I use this a lot. I have a lot of videos where I've shown this. We're going to start with methane in the North Pole, from the North Pole view. This is looking down on the Earth, and we get a pretty good view of the whole northern hemisphere. And we have data going back to Thursday, Friday, Saturday. We don't have Sunday or Monday data in yet. And I've chosen surface level. And so Thursday was the day that the 6.8 earthquake happened over near the Jan Mayen area, which was right about here. And so what we're going to see as this movie loads up and starts moving, you're going to see the wave of methane move all across that area. So we have data through Saturday, and then the last 2 days is into the forecast period, Sunday, Monday. And so now it's starting over, and we noticed that Iceland was very high in methane on Thursday. And look how it's spreading out and just moving all along. It's just coming up out of the Arctic Ocean there. It's also red coming up out of the Barents Sea and the Laptev Sea, and also the East Siberia Sea, the Chukchi Sea. The East Siberian ice shelf is right over here. And you know, the sea ice has pretty much not very thick, but it's come back to the coastlines pretty much. So this methane is coming up through the ice, whatever is there, and it's around the edges of Greenland, and then it comes around here, the sea ice, and then it comes up to here. And it hasn't come over to Novaya Zemlya yet, but it's around the coastlines now. So look at the red coming up in the Arctic. And then we're in the dark red. The measurement is down here at the bottom, and this is parts per billion is how it's measured. Excuse me. And when you get into like this yellow-green, that's 1920 parts per billion. The gold is 960. Orange is 980. The bright red is 2000. Darker red is 2020. The brick red is 2040, and then the black red is 75,000. 600. So, and we can also see over here on the west coast of the United States, that's just all black with the methane from the fires and from different stuff going on. But and it's high methane readings across the United States and down through Central America, and then all of Europe. Very high methane readings. And even though it's cooling down, it's like the methane is still releasing exponentially. And then look at India is covered up, and the Indian Ocean is, look at the black there in the ocean, and then China, and then Eastern Russia and all of that, and then the ocean. So I'm not surprised that we're having more geologic activity. There are cracks. There are lots of sinkholes around the world. I'm thinking maybe the sinkholes are a lot of them are being formed from methane explosions. Methane being released from under the surface, and it just blows a hole and makes a sinkhole. You know, things are moving. Everything is happening. Everything is moving, and let's see. I have some more views of methane that I want to show. This is the global view. This will give us a different perspective. And what you can see here, the equator runs about here through South America and then through Africa. And so above the equator is where you start getting, you can see pretty much a distinct line of demarcation with the darker green and then the lighter green. Then the blues are lesser amounts. And I remember when I first started looking at methane back in April, when I first discovered CAMS and started learning how to use it and how to read all of this. The southern hemisphere was in like the 1740 range, this blue here, and the northern hemisphere didn't have all the orange all over the place. It was mainly greens. So this is how much the methane levels have increased just since April. It's a constant, we've got this like constant background now in the northern hemisphere of this orangey level, which is about 1940 parts per billion and higher. And now you can get a different view. Look at the red coming up and over Iceland, and then remember we had, this is where the earthquake line comes, and the tectonic plate, that red line. And look at the red coming up off the coast of Siberia up here. That's not good. So and look at California and all of that. And then I have North America pulled up, to look at methane so that we can kind of zoom in to look at the extremely high methane readings in California, like where the fires are. It's like the whole state. The whole state is this black color, and look at it coming the ocean, and this is just, I've been barely able to function the last few days. So I did take a visit out to the Tahoe Reno Industrial Center on Saturday to look around there, and I'll be doing a report on that, but that brought me down too. And then this, so my heart's heavy. My heart is heavy to see, and you know, we're in the end, folks. So I'm going to stop that. And now I have sulfur dioxide pulled up, a worldwide view. Now I didn't find major releases like with a lot of red, like I see sometimes with a lot of earthquake and volcanic activity, but it's an underlying lower level of sulfur dioxide release, and it builds in the atmosphere, and the whole earth is pretty much covered in this green color, and this is parts per million, so that's a 0.5 parts per million, and then this lighter green is 1, and then when you get into the cream color, that's 2, then the gold is 5, and then 10, 20, 50, and 100. And then this number is 999 above that. And so normally when we see like the red, that's from volcanic activity. The volcano in Hawaii is still erupting. We have volcanoes up in Alaska erupting. The volcano in Mexico is still erupting. And then we've got volcanic activity down here in South America and down here in Africa. And then this red over here is from China, and that the red can be also from burning fossil fuels and industrial civilization, high pollution. And so with the higher levels of sulfur dioxide just throughout the atmosphere, it will also break down the ozone layer. So there's that. Next, I wanted to look at ozone. Okay. This is the South Pole. And this is so that you're oriented. Here's the southern tip of South America. Here's Antarctica. And this is a flipped view. This is the eastern side of Antarctica, and this is the western peninsula here. And now that they're heading into their spring and into their spring and summer down there and getting sunshine, the ozone hole is shifting. It's moving. I can't say that it's getting less. It was more uniform, spread out over the continent area, but now it's like it's morphed, and this is we have data back through Thursday and today it's 5 days. So I thought I'd just run this movie for you so that you can see what the ozone is doing in Antarctica and how this hole is kind of changing into a weird shape. I'm not sure why that is, and it's caused a thinning all the way up to South America that opens up. Now you'll see it when the movie runs back through. Now watch here, this hole is going to open up, and where you have thin ozone, you have very high ultraviolet radiation, because the ozone is what blocks out the UV rays, and we've had high solar winds coming in because of the coronal hole from the sun, so that could be affecting what's coming through and causing high UV radiation as well, I'm thinking. But look at how this hole is just like morphing around, and it's still very thin. It's measured in Dobson units, and the scale is down here at the bottom, and anything like yellow and yellow into orange and red is thicker. Now this is total column ozone reading, and this is what protects us from cosmic radiation and UV, and what holds our atmosphere in. And so without the ozone, we wouldn't have an atmosphere, and we wouldn't be able to breathe. All the oxygen would go out into space. And so once you start getting down into the greens, that's thinning of the ozone. So yellow is 300 Dobson units, and then as we go down, the yellow-green, kind of the yellowish chartreuse is 280, and then this one is 260, this one's 240, then the aqua is 220, and then the blue, the light blue, is 200. Like that blue, like the purpley blue, is 200. The darker blue is 175, and this darker blue is 150. Like that blue is 150. I'm not seeing any black right now. That would be 100 or less. So it's still quite thin, and I can't say that it's smaller in size. It's just a different shape, and South America is quite thin. We can see that a lot of South America is in this 240 range. So, and what we're going to see is some very high UV radiation in the South Pole that corresponds to this thinning that comes up, and it's to the east of the southern tip of South America. And this was brought to my attention by one of my YouTube subscribers, and we communicate. It's Max from Finland, and he emailed me about the high UV radiations, and he hadn't seen them so high in the Antarctic. And so but I just want to show you, before we look at UV, I want to show you the global view of ozone, total column. Now see the thinning here? That's where you're going to see that high UV come through. That's where you're going to see that, and see how this ozone hole comes up, and it's like a wave. It's like an ocean current almost, a little wave. And now watch, it's going to come up and go into a point. here it comes into the point here today, and then it starts over. So, and then we can see the whole mid-latitudes. They're quite thin. They are in the this range of the aqua is 220 to 240, and then the green, this green is 260. And also here is the hole, or the thinning, where it got down to 220 over Jan Mayen. Here's the little island where the earthquake was happening, and I did a whole video on ozone and the earthquake, and showed how we had an ozone hole open up right here, right around the time of the earthquake, and it spread out from Greenland all the way over to Norway. And then we had an ozone, a hole open up down here. Well, it's already thin down here, but it also opened up, I'm thinking, when we had that 6.2 down here yesterday, but I'm not able to really reference that at the moment. So what we can see is we have a huge thinning of the ozone. We're losing the ozone layer. It's in chunks and holes, and it's spotty here and there. And in some areas it's a lot thicker, which we do want. We want it thick. But where it's thin like that, you're going to have very high UV index. So let's come over now. I have the UV index for the world pulled up, and our reading goes back to Thursday through today, and we have two settings we can choose from. One is from total sky, which accounts for clouds and everything, and one is for clear sky, and this is what the UV radiation would be if you were in an area with no clouds. So I chose that one, and let's load this movie up. And this moves around depending on where sunlight is on the surface of the planet, and the UV index is down here at the bottom, and it starts with 1 in the green, 2 is olive colored, 3 is yellow, 4 is the kind of yellow gold, and then we move into 5 is tan, 6 is darker like a gold, 7 is a darker, then 8 starts into the red, and then the pink fuchsia color is 9, purple is 10, and then this blue, kind of blue purple, is 11, then the blue is 13, and then the other kind of the moving towards the aqua scale is 15, then the aqua is 18, and then there's a 3 on the end, which I think probably refers to 30. And they say anything over 3, over yellow, you should be having protection when you go out in the sunshine. So here we go. I'm just going to pause it there. And so this is from Thursday, and this is over South America. And remember that the sun, the southern hemisphere is getting more sun. It's moving towards facing the sun, and so it's going to get more of the direct UV radiation. And we can see that this mid part of South America is in the 15 to I can't really tell if it's in the 8. A little bitty part of it is in the 18 range. So that's quite high. And then down here in the Antarctic, it's like in the 11 range. So let's move forward. Let's go back. Here we are on Saturday. Here's the UV reading in the Antarctic, and that's in the 13 range now. Right here. Of course it will have spread out. And we started up again. Okay, it was quite high today. Let's go back. Trying to go back. Every click it goes back 3 hours. Now look at it over the Atlantic Ocean here, and then it goes into here in the Arctic, it goes into the 18 range. It looks like right here. And so what this means is, with high UV radiation, it's letting the sea ice down there is going to be melting faster. And Max was quite concerned and wanted me to do, I don't know if he wanted me to do a full report on it, but we can see it correlates. This is the hole, or the thinning in the ozone that I showed. This is from the Finnish Meteorological Institute UV index forecast. This is from today, and it's getting up there, and so their colors are just a different, but their scale goes up to 17 plus, but the CAM scale goes up higher than that even. So there's that. So let's go back to CAMs. Let's see, I've showed you ozone. Now I want to show you nitrogen dioxide. We haven't done this before. This is considered another greenhouse gas. It's created from pollution in the atmosphere, burning fossil fuels, but it also contributes to global warming, and it contributes to pollution. And so what I have here is back from Thursday through today, total column level, and this is the globe. And so it's changing colors depending on where that certain part of the planet is getting the sunlight, because I guess that's when it's measured, is when the sun is up. So we can see the highest levels are coming from China, and they're at the top of the scale here with this is total column nitrogen dioxide. This is parts per million. This red here is 30, and then the black is 50, and then it's a 3 on the end. I don't know what that means. But they're in the high range. This is near Beijing and the really highly populated areas there. And This nitrogen dioxide, when it gets up in the atmosphere, when it starts breaking down, it turns into acid rain, and it will destroy the ozone layer too. So anywhere you have industrial civilization, you're going to see these higher levels of this nitrogen dioxide, and then it's over the ocean. It spreads out across the planet, and we see even like here over the ocean here in the Pacific, we have a 4.5 to the 5 range of nitrogen dioxide, and a lot of North America is the 4.5 to 5 to 7 range, and then we have this higher range up here in Canada. I'm thinking this can be from forest fires too, and biomass burning. I'll have to do a study on this and present a report, but I just wanted to show you that too. And so this is just another thing adding to the pollution levels and the hazy skies and being hard to breathe and things like that. And I haven't showed carbon dioxide in a while, and our carbon dioxide readings go back to Thursday, Friday, and Saturday. And so this is global carbon dioxide. And our chart down here, it's measured in parts per million, and globally we have an overall, we can see you know, as you get above the equator, it starts getting higher, and most of the carbon dioxide is being produced from industrial civilization, but it's also being produced by the burning of the rainforests and the chopping down of the rainforests, and the dead trees give off carbon dioxide, and there are lots of dead trees around the planet, and it's just a sad situation, and my heart is heavy. Like I said, I don't ever feel happy because I feel the weight of this, and I know that it's just a matter of time as to when all life will be snuffed out because of one thing or another. So, and these readings down here, like this brown color is 414 parts per million, and then like this red brown is 418, and then this one on the end is 1,000. So I love you guys. I pray for every one of you. I just pray for everyone. So as we go forward in these end days, and I don't know how much time we have, but I don't think it's much. As we move forward in these end days, I'm praying that we have the courage to stay strong and to stay calm. And if you haven't gotten right with God and Jesus, now would be a good time. I love you, and until next time, my name is Margo, and I do offer holistic life coaching and just one-on-one talk therapy if you're interested. And my website, my new website is glc.margoshealingcorner.com, but you can get there from margoshealingcorner.com as well. I love you. God bless. Go in peace. Goodbye.